Okay, now we're going to consider the graph of an absolute value equation. So this is a program called GeoGebra, which is a really cool program for exploring these kind of things. So you can see over here I've put this point on there that I can slide up and down, and this is the graph of y equals absolute value of x, and there's our point. Okay, so we can see that these are values of y equals absolute value of x. So 0, 0 we know, and we saw 2, 2. And then when we go up this direction, we see that if x is negative 1, then y is going to equal 1, right? Because absolute value. X equals negative 2, y equals 2. X equals negative 3, y equals 3. So the absolute value makes a sort of V-shaped graph, which never goes negative, right? Because the absolute value is never negative. Now we're going to change some things. We're going to change some things in the equation and see what happens. So that little plus sign there, we're going to try, okay, so now we've changed it to y equals the absolute value of x plus 1. And now look what happens to our graph. It sort of slides over there, but we can see why. Because we're adding 1 to the x, to what comes out of the x. So negative 2 plus 1 equals negative 1, and the absolute value of that is 1. Okay? Negative 1 plus 1 is 0. So if x is negative 1, then y is 0. And so that's why that graph slides over 1. I would encourage you to, by the way, to find a program that does graphing and to play with this yourself, because it's much more enlightening when you're actually doing it yourself. Okay, and then we see, for example, that if x equals 0, then y equals 1, right? If x equals 1, then y will equal 2. Okay. Now we'll change that, what we're adding there, we'll change it to a negative 1. Sorry about the way that equation looks, but that's just the way that is. But you can see this is if we're adding a negative number inside the absolute value, you see the graph sort of slides over there. So when we're at, let's say, we can see we sort of slide back and forth here. Okay, when we're changing the number we're adding inside, it basically just slides the absolute value graph back and forth, although the vertex of it is always at 0. Okay, now we're going to change the slope inside of there. So the linear equation, so we're going to, right now it's 1. Okay, that's our friend 1, and we're going to expect if we change it to a higher number, it's going to become steeper, and there it does. Okay, but look at this, it's steeper coming in. There it is, 1 1/2, so it's 2 up and 1 over. So it's 2 is the slope. So 2 up and 1 over. But the difference is on the other side, when x goes negative, the slope changes. It turns into a negative 2 slope. Okay, over here. But that just has to do with the way the absolute value works. And so you can look at it, it's almost like a pool ball caroming off the side of a table. See, if we make the slope smaller, or like 1/2, like 0.5 or 1/2, there's our up 1 over 2. That gives us our 1/2, and there it's like a negative 1/2 on the other side. Again, sort of like a pool ball. You can see that the angle coming into the vertex is the same as the angle going out. Okay, it just switches. Okay, and that's because it really is like a linear, like a line, but it just is not allowed to go below 0. Okay. Now we're going to try changing the slope to a negative 1. So there it is. Now our slope is negative 1, but look, it looks exactly the same as it did when it was 1. Okay, because it's an absolute value. The fact that we're switching the slope around doesn't change anything. Okay, and in this case, when we go negative, though, now when we change the number inside there, when we change the number we're adding, you can see that it actually moves. So a negative 2 goes the negative 2 direction. So the vertex goes to negative 2. And you can see that that's probably the case because when we're at, let's see, let's go over here. When say we're at x equals 2, then negative 1 times 2 is negative 2, and negative 2 plus 2 is 0. And therefore the y equals 0. Oops, I'm off by a little bit there. Okay. Now we're going to consider one more case. We're going to add something on the outside of the absolute value. Okay. So on the outside of the absolute value, here we're changing number inside, so we're still doing the same basic, we're adding 0, so we wouldn't expect that the absolute value equation graph to be any different. And here we are changing the slope. Okay, that's exactly the same. Okay, we'll make that back out to slope of 1. Okay. But now watch happens when we add things to the outside. Look, it's going up and down. Now, why would it go up and down like that? Why would it go along the y-axis? Well, we can look at the absolute value part of it. Doesn't really, that's what it was before. But what we're basically doing is just making this add-on onto y. So when everything inside the absolute value comes out to 0, we add this 2 on. Now y is 2 more than that. Okay. When up in the absolute value comes out to be, let's see, when it comes out to be 0 here, now we have add a negative 1, and so the vertex is at negative 1. Okay, and so this is a way, if you see absolute values that actually do go above and below, especially below the y or the x-axis, I'm sorry. If they go below the x-axis or they're off the x-axis, you know that something's being added outside the absolute value. Okay, because that's the one way you can get it off of the x-axis.